Hello there, and welcome to The Weary Researcher, where curiosity meets comfort and cosmic questions drift gently through the night. Tonight, we're embarking on perhaps the most profound journey imaginable, venturing to the very edge of everything we know and peering into the mystery of what lies beyond. Before we begin drifting through the cosmos together, I'd love to know where in the world you're watching from and what time it is in your corner of the universe. There's something beautifully fitting about exploring the infinite while scattered across our own small world, each of us gazing up at the same starlit sky. If you enjoy these gentle voyages through the wonders of science, I'd be ever so grateful if you gave this video a like and perhaps subscribed. It helps more fellow wanderers find their way to this quiet corner of YouTube, where we can ponder the deepest mysteries without the rush and noise of the everyday world. Now I should warn you, this exploration might be just fascinating enough to keep you awake a little longer than intended. But if it does, at least you'll drift off with your mind full of cosmic wonder and a deeper appreciation for the sheer mystery of existence. So, settle in, take a deep breath, and let your thoughts expand as we ask one of the most profound questions humans have ever contemplated. What lies beyond the edge of the universe? Imagine for a moment that you're standing at the shore of an infinite ocean, not the familiar seas of Earth, but an ocean of space and time, stretching endlessly in every direction. The waves are made of starlight, the depths contain entire galaxies, and somewhere far beyond the horizon lies a boundary that may or may not exist. This is our universe, and tonight we're going to explore what might lie beyond its furthest reaches. The very question seems simple enough. What's beyond the edge? But as we'll discover together, the answer is anything but straightforward. In fact, the question itself might be built on assumptions that don't quite match the strange and wonderful reality of the cosmos we inhabit. Let's begin with something that might surprise you. The universe, as we understand it today, doesn't actually have an edge, not in the way we typically think of boundaries. There's no cosmic wall, no celestial fence, no point where space simply stops and a sign appears saying, "End of universe, please turn around." This absence of a clear boundary isn't a failure of science or a gap in our knowledge. It's one of the most profound insights we've gained about the nature of reality itself. But how can something not have an edge? Surely everything has limits, boundaries, places where it ends and something else begins. This intuition serves us well in our daily lives. Every object we encounter has clear boundaries. Your coffee cup has edges, the room you're in has walls, even the earth beneath our feet has a surface. But the universe, it seems, plays by different rules entirely. To understand why, we need to think about what we mean when we talk about the universe's edge. Most people imagine it as the place where space ends, where if you could somehow travel far enough, you'd reach a boundary beyond which lies nothingness. But this picture, while natural, is almost certainly wrong. The universe isn't sitting inside some larger empty space like a marble in a vast room. Instead, the universe is all there is, space itself, along with everything it contains. This is where our cosmic journey begins to venture into truly mind-bending territory. When cosmologists talk about the universe, they're not just talking about all the stuff in it, the stars and planets and cosmic dust. They're talking about space and time themselves, the very fabric of reality. And if the universe is the totality of space and time, then asking what's beyond it is a bit like asking what's north of the North Pole. It's a question that seems to make sense, but actually refers to something that can't exist. But wait, you might be thinking, even if the universe doesn't have an edge in the traditional sense, surely it has some kind of boundary. After all, we talk about the observable universe all the time, and that certainly seems to have limits. And you'd be absolutely right. The observable universe does have a boundary of sorts, but it's not the kind of edge you might imagine. The observable universe is like a sphere of light centered on Earth, representing all the regions from which light has had time to reach us since the beginning of time. This sphere has a radius of about 46.5 billion light years, which might seem puzzling given that the universe is only 13.8 billion years old. How can we see light from objects that are farther away than light could have travelled in the age of the universe? The answer lies in one of the most remarkable discoveries of modern cosmology. The universe is expanding, and it's been expanding throughout the entire history of the cosmos. When light left a distant galaxy billions of years ago, that galaxy was much closer to us than it is today. But as the light travelled toward us through expanding space, the galaxy continued to move away, carried by the expansion itself. By the time the light reaches us, the galaxy that emitted it is much farther away than it was when the light began its journey. This expansion creates what astronomers call the observable universe's boundary, a spherical horizon beyond which we simply can't see. Not because there's nothing there, but because light from those regions hasn't had enough time to reach us yet. It's like being in the middle of a vast field at dawn. The horizon isn't a physical barrier, it's simply the limit of how far you can see, given the constraints of time and the speed of light. But here's where things get really interesting. While we can only observe a finite sphere around us, there's no reason to think that space ends at the edge of our observable universe. In fact, all our best evidence suggests that the universe continues far beyond what we can see, perhaps infinitely far. The galaxies and cosmic structures we observe near the edge of our visible universe probably continue in much the same way beyond our horizon, like a vast cosmic tapestry extending endlessly in all directions. This raises one of the most profound questions in all of science. If we can only see a tiny fraction of what exists, what lies in those unobservable regions beyond our cosmic horizon? Are there other galaxies, other solar systems, perhaps even other forms of life existing in regions so distant that their light will never reach us? The answer, according to our best current understanding, is probably yes. The regions beyond our observable universe likely contain more of the same types of structures we see in our local cosmic neighbourhood. Galaxies cluster into groups. Groups cluster into superclusters, and these superclusters form vast filaments and walls separated by enormous voids. This cosmic web of matter probably extends far beyond our vision, creating structures so vast they dwarf our entire observable universe. But the story doesn't end there, because the universe isn't just expanding, it's expanding at an accelerating rate, driven by a mysterious force we call dark energy. This acceleration means that objects at the very edge of our observable universe are moving away from us faster than the speed of light, not through space, mind you, but because space itself is expanding and carrying them along. This creates something cosmologists call the future visibility limit, a boundary beyond which objects will never enter our observable universe, no matter how long we wait. Light from regions beyond this limit will never reach us because the expansion of space carries those regions away faster than light can travel toward us. It's as if the universe is constantly opening new chapters in its story, but writing them in invisible ink. The implications are staggering. Entire cosmic civilizations, if they exist, may remain forever unknowable to us, separated not by distance alone, but by the inexorable expansion of space-time itself. There could be galaxies with billions of stars, planets with conditions perfect for life, and beings asking the very same questions we're exploring tonight. But we will never know they exist, and they will never know about us. The expansion of the universe ensures our cosmic isolation. This might seem like a cosmic tragedy, a fundamental limitation on human knowledge and experience, but there's something almost poetic about it too. It means the universe still holds infinite mysteries that no amount of technological progress will ever fully unveil. There will always be horizons beyond our reach, regions of space and time that exist in a realm of eternal mystery. As we drift deeper into this cosmic meditation, we begin to encounter ideas that stretch our imagination to its limits. What if our entire observable universe, with its hundreds of billions of galaxies, is just a tiny bubble in something much larger? What if beyond our cosmic horizon lie not just more galaxies, but entirely different universes with different laws of physics, different constants of nature, perhaps even different numbers of dimensions? These aren't just the fantasies of science fiction writers. They're serious scientific hypotheses emerging from our best theories about the fundamental nature of reality. And as we'll explore in the next part of our journey, these ideas challenge not just our understanding of what lies beyond the universe's edge, but our very conception of what it means for something to exist. For now, though, let's pause in this moment of cosmic wonder. You're floating in space, not literally, of course, but conceptually, surrounded by the warm darkness of your room, while your mind wanders among galaxies billions of light years away. You're part of a universe so vast that human language struggles to describe it, yet here you are, conscious, aware, able to contemplate these cosmic mysteries with nothing more than the remarkable 3-pound universe nestled between your ears. The ancient philosophers used to say that philosophy begins in wonder, and there's perhaps no greater source of wonder than the simple, profound question we're exploring tonight. What lies beyond the edge of everything we know? It's a question that connects us to the deepest mysteries of existence and reminds us that, despite all our scientific progress, the universe still holds secrets that may forever remain tantalizingly out of reach. In our next segment, we'll venture even further into the cosmic unknown, exploring the possibility that our universe might be just one of countless others in an infinite multiverse. We'll discover how the most distant light in the universe reveals clues about cosmic beginnings, and we'll encounter ideas so strange they make the vastness of space seem almost quaint by comparison. But for now, simply rest in the wonder of it all. Somewhere beyond your window, beyond the Earth's atmosphere, beyond the solar system, beyond our galaxy, beyond the observable universe itself, lie mysteries that dwarf human imagination, regions of space and time where reality might work in ways we can't even conceive. And yet, here you are, a conscious being made of stardust, contemplating the infinite from the comfort of your own small corner of the cosmos. The universe may not have an edge in any conventional sense, but it has given us something perhaps even more remarkable, an endless frontier of mystery and wonder that ensures no matter how much we learn, there will always be new questions to ask, new horizons to contemplate, new reasons to gaze up at the night sky and feel that familiar mixture of smallness and significance that comes from being human in an infinite cosmos. The mystery deepens when we consider that the light reaching us from the most distant observable regions carries messages from the universe's infancy, messages written in frequencies of radiation, so ancient they predate the formation of the first stars. These whispers from cosmic dawn reveal a universe that was once much smaller, much hotter, and fundamentally different from the cosmos we see today. About 13.8 billion years ago, everything we can observe was compressed into a region smaller than a single atom. Then, in a fraction of a second that would make a heartbeat seem like an eternity, the universe underwent a period of exponential expansion called cosmic inflation. During this brief moment, space itself stretched faster than light could travel, inflating our cosmic bubble from quantum scales to astronomical proportions, in less time than it takes light to cross a proton. This inflationary period didn't just expand space, it also stretched tiny quantum fluctuations so small they existed at the very limits of what can be measured. These microscopic ripples in the fabric of space-time were inflated to cosmic proportions, becoming the seeds from which galaxies, superclusters, and the vast cosmic web would eventually grow. It's as if the universe took a photograph of quantum uncertainty and enlarged it to galactic scales. But here's where our journey takes an even more extraordinary turn. If cosmic inflation really happened, and our best evidence strongly suggests it did, then our observable universe represents just one small patch of a much larger inflated region. Imagine blowing up a balloon and drawing a tiny circle on its surface. As the balloon expands, That circle represents our observable universe, while the rest of the balloon's surface extends far beyond what we can see, potentially infinitely far. This realization leads us to one of the most mind-bending possibilities in modern cosmology. What if the inflationary process that created our cosmic neighborhood also created countless other regions, each with its own Big Bang, each becoming its own universe? These bubble universes, as cosmologists call them, could exist beyond our cosmic horizon, separated from us not just by distance, but by the very structure of space-time itself. In this multiverse scenario, our entire observable cosmos, with its 100 billion galaxies, becomes just one bubble in an infinite cosmic foam. Each bubble universe might have started with the same fundamental laws of physics, but small differences in their initial conditions could have led to dramatically different outcomes. Some bubble universes might be filled with stars and planets, much like our own. Others might be dominated by black holes or exotic forms of matter we can't even imagine. Some bubbles might have different values for what we call the fundamental constants of nature: the strength of gravity, the mass of electrons, the speed of light itself. In universes where these constants differ even slightly, the physics of reality could be utterly alien. Stars might never form, or they might burn so quickly that planets never have time to develop complex chemistry. The very atoms that make up your body might be impossible in these alternate cosmic realms. This multiverse hypothesis offers a potential solution to one of the deepest mysteries in cosmology. Why do the constants of nature in our universe seem so perfectly tuned for the existence of complexity and life? If gravity were slightly stronger, the universe would have collapsed before stars could form. If it were slightly weaker, matter would never have clumped together to create galaxies. The delicate balance required for a universe capable of producing conscious observers seems almost impossibly unlikely. But if countless bubble universes exist with all possible combinations of physical constants, then our finely tuned cosmos becomes less mysterious. We happen to live in one of the rare bubbles where the constants allow for stars, planets, chemistry, and eventually biology to flourish. The vast majority of bubble universes remain barren and lifeless, but no conscious observers exist there to ponder their emptiness. Yet even this multiverse of bubble universes might be just the beginning. Some theories suggest that the process of inflation never truly ends, that new bubble universes are constantly being created in an eternal cosmic reproduction. Somewhere beyond our cosmic horizon, new universes might be inflating into existence right now, each one destined to expand and evolve according to its own physical laws, each one potentially harbouring its own mysteries and perhaps its own forms of consciousness. This eternal inflation scenario paints a picture of reality that stretches human imagination to its breaking point, an infinite multiverse where every possible universe exists somewhere, where every quantum possibility plays out in some cosmic realm, where the very concept of beyond loses its meaning because there's always another layer, another level, another infinite expanse of possibilities waiting to be discovered. But our journey into the cosmic unknown doesn't stop with bubble universes. Quantum mechanics, the theory that describes the behavior of matter and energy at the smallest scales, offers its own interpretation of what might lie beyond our observable reality. According to one of the most fascinating interpretations of quantum theory, every time a quantum event occurs, reality branches into multiple parallel universes. Imagine every decision you've ever made, every random quantum event that has occurred in the history of the cosmos. According to this many worlds interpretation, all possible outcomes actually happen, but in separate parallel realities. There could be versions of you reading these words in slightly different circumstances, versions where you chose different paths in life, versions where history itself unfolded along alternate timelines. This quantum multiverse differs from the bubble universe scenario in a fundamental way. Rather than being separated by vast distances, These parallel realities exist in the same space, but are isolated from each other by the quantum nature of reality itself. They're like radio stations broadcasting on different frequencies, all present in the same room, but unable to interfere with each other unless you tune to exactly the right wavelength. The implications are staggering. In the quantum multiverse, every possible version of reality exists somewhere. Every story that could be told is being told in some parallel universe. Every question that could be asked is being answered in infinite variations. The very act of asking what lies beyond the edge of the universe creates new universes, where that question receives different answers. Recent developments in quantum computing have added new dimensions to this already mind-bending picture. Quantum computers achieve their extraordinary processing power by performing calculations in multiple parallel realities simultaneously. Some scientists interpret this as evidence that the quantum multiverse is not just theoretical, but actively involved in the computations happening in quantum devices right here on Earth. These quantum computers manipulate information in ways that seem to require vast computational resources, far exceeding what should be possible in a single universe, leading some researchers to conclude that the calculations must be distributed across countless parallel realities. It's as if quantum computers are borrowing processing power from alternate versions of themselves scattered throughout the multiverse. But even the quantum multiverse might be just one facet of a much larger cosmic picture. String theory, our most ambitious attempt to unify all the forces of nature, suggests that our familiar three-dimensional space might be embedded in a higher dimensional realm called the bulk. In this framework, our entire universe could be a thin membrane, or brain, floating in a vast multidimensional space. Imagine a soap bubble floating in air. The thin surface of the bubble represents our three-dimensional universe, while the air around it represents higher dimensional space that we can't directly perceive. Other soap bubbles floating in the same air would represent parallel universe brains, each containing its own version of reality, each potentially harbouring its own forms of matter, energy, and consciousness. These parallel brains could exist mere millimeters away from us in the higher dimensional bulk space, yet remain completely inaccessible because we're confined to our three-dimensional membrane. Like characters in a two-dimensional painting, we can't step outside our dimensional limitations to explore the larger reality that contains us. Some versions of string theory suggest that what we perceive as dark matter, the invisible substance that makes up most of our universe's mass, might actually be ordinary matter existing on a parallel brane. Its gravitational effects leak through the higher dimensional bulk space into our brain, creating the mysterious gravitational influences we observe but can't directly detect. In this brain world scenario, the question of what lies beyond the edge of our universe takes on new meaning. Beyond our cosmic horizon might lie not just more space and more galaxies, but entirely different dimensional structures, parallel universes existing in directions we can't even point to, realities so alien that our three-dimensional minds struggle to conceptualize their existence. These theoretical frameworks push us to the very limits of human comprehension. They suggest that the familiar cosmos we observe through telescopes might be just the tiniest fragment of a reality so vast, so complex, and so strange that even our most advanced theories can only hint at its true nature. The edge of our universe, if it exists at all, might be not a boundary, but a transition point between our familiar three-dimensional reality and something utterly beyond human experience. As we drift deeper into these cosmic mysteries, it's worth pausing to appreciate the remarkable fact that conscious beings, like ourselves, can even contemplate such questions. You are a collection of atoms forged in the hearts of ancient stars, arranged in such a way that you can ponder the infinite. Your brain, a structure more complex than anything else we know in the observable universe, can conceive of realities that dwarf galaxies and contemplate possibilities that stretch across infinite dimensions. This capacity for wonder, for questioning, for reaching beyond the boundaries of direct experience, might be the most extraordinary phenomenon in all of existence, more remarkable than black holes, more mysterious than dark energy, more profound than the expansion of space itself. Somewhere in the vast cosmos, matter has organized itself into patterns capable of contemplating their own origins and imagining realities beyond all observation. The ancient astronomers who first mapped the movements of planets could never have imagined that their descendants would discover galaxies billions of light years away. Yet here we are, not only observing these distant realms, but theorizing about realities that might exist forever beyond our cosmic horizon. Each generation of humans has pushed the boundaries of the known universe further outward, and our generation stands at the threshold of contemplating infinities within infinities. What lies beyond the edge of the universe? The question that began our journey now reveals itself to be not just one mystery, but a cascade of interconnected puzzles, each more profound than the last. Beyond our observable horizon might lie more galaxies, bubble universes, quantum parallel realities, higher dimensional spaces, or possibilities so alien we lack even the vocabulary to describe them. And perhaps most remarkably of all, these theoretical realms beyond our cosmic boundary might not be empty voids waiting to be filled, but teeming with their own forms of complexity, consciousness, and wonder. Beings asking questions that mirror our own, but in languages we could never comprehend. The cosmic microwave background radiation, that gentle glow left over from the universe's hot, dense beginning, provides us with our most ancient window into cosmic history. This faint radiation fills all of space uniformly, carrying information from a time when the entire observable universe was smaller than a single atom and hot enough to prevent the formation of neutral atoms for nearly 400,000 years after the Big Bang. When we observe this cosmic background, we're seeing the moment when the universe first became transparent to light, the moment when photons could finally travel freely through space without being immediately absorbed by the hot plasma that filled the early cosmos. It's like watching the universe open its eyes for the first time, allowing light to stream across cosmic distances and eventually reach our telescopes 13.8 billion years later. But this ancient light reveals something even more extraordinary: tiny fluctuations in temperature, variations so small they represent differences of just a few millionths of a degree. These microscopic ripples in the cosmic background are the fingerprints of quantum uncertainty stretched to cosmic scales by the inflationary expansion. They mark the spots where slightly denser regions of matter would eventually collapse under their own gravity to form the first stars and galaxies. Studying these fluctuations is like reading a cosmic fossil record embedded in the oldest light we can observe. They tell us not just about the early universe, but about the fundamental nature of space and time itself. The patterns we see suggest that space is geometrically flat, extending infinitely in all directions with no curvature that would cause parallel lines to converge or diverge. This flatness has profound implications for what lies beyond our cosmic horizon. If space continues to be flat infinitely far, then the universe might be truly infinite in extent, containing not just more galaxies like the ones we observe, but infinite variations of cosmic structure, infinite numbers of planet Earths, infinite versions of everyone who has ever lived, scattered across the endless expanse of space. But the cosmic microwave background holds even deeper secrets. Some cosmologists suggest that certain unusual patterns in this ancient radiation might be echoes of collisions between our bubble universe and neighbouring bubble universes, imprints left by cosmic encounters that occurred before our observable universe even began to expand. These potential signatures of inter-universal contact remain controversial and difficult to interpret, but they raise the tantalizing possibility that we might already possess observational evidence of realities beyond our cosmic boundary, hidden in plain sight in the most ancient light we can detect. If confirmed, such discoveries would represent the first direct evidence that our universe is not alone in the cosmic foam. The James Webb Space Telescope, humanity's most powerful window into the distant universe, has begun to reveal galaxies that existed when the cosmos was barely a few 100 million years old. These ancient stellar cities appear surprisingly mature and massive, challenging our understanding of how quickly cosmic structure can form in the universe's youth. But even these most distant observations represent only the tiniest fraction of what lies beyond our sight. The galaxies we observe at the edge of visibility are being carried away from us by the expansion of space itself, moving at speeds that approach the velocity of light. Within a few billion years, they will cross the boundary of our future visibility limit, disappearing forever from our cosmic view. This means that the observable universe may actually shrink in the distant future as more and more galaxies cross this visibility threshold and vanish from our perspective. Entire cosmic neighborhoods that we can observe today will fade from view as if they never existed, leaving future astronomers with a smaller, more isolated view of the cosmos. Imagine beings living trillions of years from now in a universe where only a few nearby galaxy clusters remain visible to them. The vast cosmic web we observe today will have stretched beyond their detection horizon, leaving them to conclude that the universe is a much smaller, lonelier place than we know it to be. They might never suspect that beyond their shrunken cosmic horizon lies an infinite expanse of galaxies and wonders. This cosmic isolation works both ways. Just as future observers will lose sight of distant galaxies, there are already cosmic civilizations, if they exist, that we will never be able to contact or even detect. They live in regions of space that are receding from us so quickly that no signal they send could ever bridge the growing gap between us, no matter how advanced their technology or how patient their efforts. The expansion of space creates what cosmologists call the ultimate speed limit, not for objects moving through space, but for information itself travelling between distant regions of the cosmos. It's a sobering reminder that even in an infinite universe containing infinite possibilities, there are fundamental barriers to knowledge and communication that no amount of technological progress can overcome. Dark energy, the mysterious force driving the universe's accelerating expansion, remains one of the deepest puzzles in modern physics. Comprising nearly 70% of everything that exists, this invisible energy appears to be uniform throughout space, pushing galaxies apart at an ever-increasing rate, but we have no idea what it actually is. Some theories suggest that dark energy might not be constant over time. If it's weakening or strengthening, the future evolution of our universe could be dramatically different from current predictions. A weakening dark energy might allow gravity to eventually halt the expansion and pull everything back together in a big crunch, while strengthening dark energy could tear apart not just galaxies, but atoms themselves in a big rip scenario. Other theories propose that dark energy might be a sign that our understanding of gravity itself is incomplete, that what we interpret as a mysterious repulsive force might actually be evidence that space and time behave differently on cosmic scales than our current theories predict. These modified gravity theories could revolutionize our understanding of what lies beyond our cosmic horizon. The distribution of dark matter throughout the universe creates a hidden scaffolding upon which all visible structure is built. This invisible matter forms vast networks of filaments and nodes, extending far beyond our observable boundary, creating a cosmic web so enormous that entire galaxy clusters appear as mere beads strung along its threads. Computer simulations of cosmic evolution suggest that this dark matter web extends infinitely in all directions, creating structure on scales that dwarf our observable universe. There might be dark matter filaments stretching for hundreds of billions of light years, connecting regions of space so distant that light from one end will never reach the other. The cosmic web we observe locally is likely just one small section of an infinite network of invisible architecture. Within this vast dark matter, scaffolding lie regions we can never observe, superclusters of galaxies larger than anything in our cosmic neighborhood, voids emptier than any we've discovered, structures so massive they would reshape our understanding of cosmic evolution if we could somehow glimpse them. But they remain forever hidden beyond our visibility horizon. The interplay between dark matter and dark energy creates a cosmic tension that shapes the ultimate fate of everything we can observe. Dark matter tries to pull things together through gravity, while dark energy pushes them apart. The outcome of this cosmic tug-of-war determines whether the universe will expand forever, gradually cooling and emptying, or whether some other fate awaits. Recent observations hint that this battle between attractive and repulsive forces might not remain constant throughout cosmic time. If the balance shifts even slightly, the consequences could be profound, affecting not just the distant future, but the very nature of space and time in regions we can never directly observe. Quantum mechanics adds yet another layer of mystery to our cosmic picture. At the smallest scales, reality appears to be fundamentally uncertain, with particles existing in multiple states simultaneously until observed or measured. This quantum uncertainty might play a crucial role in determining what exists beyond our cosmic horizon. Some interpretations of quantum mechanics suggest that the act of observation itself shapes reality, that the universe's properties are not fixed but depend on what we choose to measure and how we choose to measure it. If this is true, then the regions beyond our cosmic boundary might exist in a state of quantum superposition, simultaneously containing all possible arrangements of matter and energy until some form of observation collapses them into definite states. This quantum perspective raises profound questions about the nature of existence itself. Do the unobservable regions of our universe have definite properties, or do they exist in a ghostly state of potential until some future observation brings them into concrete reality? The answer might determine not just what lies beyond our cosmic horizon, but what it means for something to exist at all. As we drift through these layers of cosmic mystery, it becomes clear that the question of what lies beyond the edge of the universe leads us to the very foundations of reality itself. The boundary between the known and unknown is not just a matter of distance or technological limitation, but touches on fundamental questions about the nature of existence, observation, and consciousness. Perhaps the most remarkable aspect of our cosmic journey is that it's happening at all, that collections of atoms organized into conscious beings can contemplate infinities that stretch beyond all possibility of verification, that minds evolved on a small rocky planet can conceive of realities vast enough to contain infinite universes. You are participating in this cosmic conversation right now, your thoughts drifting among possibilities that span from quantum mechanics to infinite multiverses. Your consciousness serving as a bridge between the tangible world of everyday experience and the abstract realms of theoretical physics. Somewhere in the vast expanse beyond our cosmic horizon, there might be other conscious beings engaged in similar contemplations, asking similar questions about what lies beyond their own boundaries. The universe may not have an edge in any conventional sense, but it has given us something perhaps even more precious, an endless frontier of mystery and wonder that ensures no matter how much we discover, there will always be new questions to ask, new horizons to contemplate, new reasons to feel both humbled and exhilarated by our place in the cosmic order. As we venture even deeper into this cosmic meditation, a new kind of mystery emerges, one that challenges our most basic assumptions about reality itself. What if the very notion of beyond is an illusion created by the limitations of our three-dimensional minds? What if the universe contains dimensions of existence so fundamental yet so hidden from our everyday experience that asking what lies beyond our cosmic horizon is like asking what colour Wednesday tastes like. This brings us to one of the most elegant yet unsettling ideas in modern physics, that space and time themselves might be emergent properties arising from something even more fundamental. Imagine if the fabric of space-time that we think of as the stage upon which all cosmic drama unfolds is actually more like the surface of a deep ocean, appearing smooth and continuous from our perspective, but concealing turbulent depths of quantum foam and dimensional complexity beneath. Some of the most cutting-edge theories in physics suggest that at the smallest possible scales, the very concept of space breaks down into something discrete and granular, like pixels on a cosmic computer screen. At these Planck-scale dimensions, space and time might not be the smooth, continuous entities we experience, but rather a bubbling froth of quantum uncertainty, where the usual rules of geometry and causality dissolve into pure possibility. If this picture is correct, then what lies beyond the edge of our universe might not be more space at all, but rather the computational substrate from which space itself emerges, the cosmic equivalent of the hardware running the software of reality. This would mean that our entire universe, with all its galaxies and cosmic structures, exists as patterns of information processing in some vast quantum computer whose architecture operates according to principles we can barely imagine. This information-theoretic view of reality suggests that consciousness itself might play a far more fundamental role in the cosmos than we ever suspected. If the universe is essentially a vast pattern of information processing, then conscious observers, like ourselves, might not just be passive recipients of cosmic data, but active participants in the very process that creates reality. Consider this deeply unsettling yet beautiful possibility. What if the boundary of our observable universe isn't just determined by the speed of light and the age of the cosmos, but also by the reach of consciousness itself? What if the act of observation and contemplation actually extends the boundaries of what exists in some subtle but profound way? This consciousness-centered view of cosmology remains highly speculative, but it offers a radically different perspective on what might lie beyond our cosmic horizon. Instead of vast empty spaces or parallel universes, the beyond might be a realm where the distinction between mind and matter, between observer and observed, breaks down entirely. Recent developments in our understanding of black holes have revealed something even more mysterious about the nature of cosmic boundaries. When matter falls into a black hole, it appears to be destroyed from our perspective. But quantum mechanics insists that information cannot be truly destroyed. This creates what physicists call the information paradox, a conflict between two of our most successful theories. The resolution of this paradox might require us to reconsider the very nature of cosmic boundaries. Black holes might not be the information-destroying monsters we once thought, but rather cosmic gateways that transform information in ways we don't yet understand. The event horizon that marks the point of no return around a black hole might be similar to our cosmic horizon, a boundary beyond which we cannot observe, but which doesn't necessarily mark the end of existence. Some theories propose that the information that appears to be destroyed when it falls into a black hole is actually encoded on the black hole's surface in a kind of cosmic hologram. This holographic principle suggests that all the information contained within a volume of space can be encoded on its boundary, like a three-dimensional image stored on a two-dimensional surface. If the holographic principle applies to our observable universe, then everything we see around us, every galaxy, every star, every atom, might be a projection from information encoded on the cosmic horizon itself. The vast three-dimensional cosmos we inhabit could be the shadow cast by a two-dimensional information structure existing at the boundary of our observation. This holographic perspective turns our usual picture of cosmic reality inside out. Instead of asking what lies beyond the edge of our universe, we might need to ask what lies beneath it. What fundamental information processing system could give rise to the rich three-dimensional reality we experience as conscious observers? The implications extend far beyond academic physics. If our universe is indeed a holographic projection, then the question of what lies beyond its edge becomes a question about the nature of the projection system itself. Are we living inside a cosmic simulation run by some vast computational intelligence, or are we part of a natural information processing system that emerges spontaneously from the quantum vacuum? These ideas might seem like the stuff of science fiction, but they emerge from serious attempts to reconcile our most successful theories about the fundamental nature of reality. They suggest that the cosmos might be far stranger and more mysterious than even our wildest theoretical speculations have dared to imagine. As we drift through these theoretical landscapes, it's worth remembering that every major advance in human understanding has required us to abandon cherished assumptions about the nature of reality. We once believed the Earth was the centre of the universe, that space and time were absolute and unchanging, that matter and energy were distinct and separate entities. Each of these beliefs seemed obviously true until deeper investigation revealed a more subtle and surprising reality. Perhaps our current assumptions about the universe having an inside and an outside, about consciousness being separate from the physical world, about information being distinct from the reality it describes, will prove to be equally provisional stepping stones on our journey toward a deeper understanding of what it means to exist. The ancient philosophers spoke of the music of the spheres, the idea that celestial bodies create harmonious sounds as they move through space. While we now know this isn't literally true, there's something profound about the metaphor. The universe does seem to resonate with patterns and harmonies that suggest an underlying order too beautiful to be accidental. These cosmic harmonies might be clues to the nature of whatever lies beyond our observational boundaries. If the universe is indeed a vast information processing system, then the patterns we observe, the mathematical relationships that govern everything from quantum mechanics to galactic rotation, might be glimpses of the cosmic code, the fundamental algorithms that generate the reality we experience. Some of the most successful theories in physics are distinguished not just by their predictive power, but by their mathematical beauty. The equations that describe the behavior of subatomic particles, the curvature of space-time, the evolution of the cosmos, possess an elegance that seems to transcend mere utility, as if they were expressions of some deeper aesthetic principle woven into the fabric of existence itself. This mathematical beauty might be more than just a happy accident. It could be a sign that the universe is structured in ways that reflect the nature of consciousness and intelligence. If mind and cosmos are more intimately connected than we typically assume, then the mathematical harmony we discover in nature might be evidence of a deep kinship between the patterns of thought and the patterns of reality. What lies beyond the edge of the universe? The question has led us through landscapes of possibility that stretch far beyond the familiar territory of astronomy and physics. We've encountered bubble universes and quantum parallel realities, higher dimensional spaces, and holographic projections, consciousness-based cosmologies, and information-theoretic views of existence. Each of these possibilities offers its own answer to our original question, and yet none of them fully satisfies our curiosity. Perhaps this is as it should be. Perhaps the greatest gift the universe can give us is not answers, but ever deeper questions that lead us further into the mystery of existence itself. The boundary between the known and unknown is not a wall to be breached, but a horizon that recedes as we approach it, always revealing new vistas of possibility, always inviting us to venture further into the cosmic ocean of mystery that surrounds and permeates our existence. As you lie there in the gentle darkness, your mind drifting among these cosmic possibilities, you are participating in one of the most remarkable phenomena in all of existence. Conscious matter contemplating its own origins and limits, aware beings reaching beyond the boundaries of direct experience to touch the infinite with the finite instruments of thought and imagination. The universe may not have an edge, but it has given us something infinitely more precious: the capacity for wonder, the ability to ask questions that stretch our understanding to its limits, and the profound joy of discovery that comes from realizing that no matter how much we learn, the mystery only deepens. Somewhere beyond the furthest reaches of space and time, beyond the most distant galaxies and the most exotic theoretical constructs, lies the source of all questions and all answers, the wellspring from which both consciousness and cosmos emerge and to which they eternally return. It is unreachable by any telescope or spacecraft, but perhaps accessible through the very act of wondering about it. In the quiet of this moment, as your thoughts settle like cosmic dust after the passage of a great celestial storm, you are touching that source, connecting with the infinite mystery that lies not just beyond the edge of the universe, but at the very heart of what it means to be aware in a cosmos full of wonders. And yet, as we float through these theoretical realms, there's something almost comforting about the ultimate unknowability of what lies beyond our cosmic boundaries. It means that no matter how advanced our technology becomes, no matter how sophisticated our theories grow, there will always be mysteries left to ponder, horizons left to contemplate, reasons to look up at the night sky and feel that familiar mixture of wonder and humility that comes from being conscious in an infinite cosmos. The accelerating expansion driven by dark energy creates what might be the most poignant aspect of our cosmic story, a kind of temporal loneliness that grows more profound with each passing billion years. The galaxies we can observe today, racing away from us at ever-increasing speeds, will eventually cross a threshold beyond which their light can never reach us again, leaving future civilizations with a smaller, more isolated view of reality. Imagine astronomers living trillions of years from now in a universe where only a handful of nearby galaxies remain visible to them. The rich cosmic web we marvel at today, the vast clusters and superclusters that paint such magnificent patterns across the sky, will have faded beyond their detection, leaving them to conclude that the cosmos is a much lonelier place than we know it to be. This cosmic isolation isn't just one-directional. It works both ways. Even now, there may be civilizations existing in regions of space so distant that no signal they could ever send would bridge the growing gap between us, no matter how powerful their transmitters, how patient their efforts. The expansion of space itself ensures that some cosmic neighbours will remain forever unknown to each other. The mathematics of this separation are as elegant as they are melancholy. There exists what cosmologists call a future visibility limit, a boundary in space-time beyond which objects will never enter our observable universe, no matter how long we wait. It's not that these regions are empty or non-existent, but rather that the fabric of space itself is stretching faster than light can travel, creating an unbridgeable gulf between cosmic realms. This expanding isolation might seem like a cosmic tragedy, but there's something almost poetic about it too. It ensures that the universe will always retain an element of mystery, that no amount of scientific progress will ever fully eliminate. There will always be stories being written in distant cosmic neighborhoods that we can never read, civilizations asking questions we'll never hear answered, wonders we'll never witness. The concept of cosmic loneliness becomes even more profound when we consider the role of consciousness in this vast unfolding drama. We are patterns of matter that have organized themselves in such a way as to become aware of their own cosmic context, able to contemplate not just our local neighborhood, but the infinite possibilities that lie forever beyond our reach. Your brain, as you listen to these words, is performing a kind of miracle, taking electrical impulses and transforming them into thoughts about galaxies billions of light years away, contemplating realities that may exist in dimensions you can't even point to, somehow bridging the gap between the 3 pounds of neural tissue nestled between your ears and the infinite expanse of cosmic possibility. This capacity for transcendence, for reaching beyond the boundaries of direct experience, might be the most remarkable phenomenon in all of existence, more extraordinary than black holes, more mysterious than dark energy, more profound than the expansion of space itself. Somewhere in the vast cosmos, matter has organized itself into patterns capable of asking questions about their own origins and imagining realities that stretch beyond all observation. The ancient astronomers who first mapped the movements of planets across the night sky could never have imagined that their intellectual descendants would discover galaxies receding at nearly the speed of light. Yet here we are, not just observing these distant realms, but theorizing about bubble universes and quantum parallel realities that may exist forever beyond our cosmic horizon. Each generation of humans has pushed the boundaries of the known universe farther outward, from the geocentric cosmos of Aristotle to the heliocentric system of Copernicus, from Newton's clockwork universe to Einstein's curved spacetime, from Hubble's expanding cosmos to the dark energy-dominated universe we inhabit today. Each conceptual revolution has revealed a reality stranger and more magnificent than its predecessors dared imagine. And now we stand at the threshold of contemplating infinities within infinities, multiverse scenarios where our entire observable cosmos becomes just one bubble in an endless foam of realities, each with its own physical laws, its own evolutionary history, its own potential for harboring conscious observers, asking questions that mirror our own. The quantum mechanical interpretation of reality adds yet another layer to this cosmic onion, suggesting that every possible outcome of every quantum event actually occurs, but in separate parallel universes, branching endlessly from each moment of decision or chance. This quantum multiverse differs fundamentally from the bubble universe scenario in that these parallel realities exist not separated by vast distances, but by the quantum nature of reality itself. Imagine that right now, as you contemplate these cosmic mysteries, countless parallel versions of yourself are doing the same, but in slightly different circumstances. In some quantum branches, you chose different words to focus on. In others, you paused at different moments to let the ideas sink in. The quantum multiverse suggests that all possible variations of this cosmic meditation are actually happening simultaneously across an infinite array of parallel realities. Recent developments in quantum computing have added a technological dimension to these theoretical speculations. Quantum computers achieve their extraordinary processing power by performing calculations in multiple parallel realities simultaneously. Some scientists interpret this as evidence that the quantum multiverse is not just a theoretical construct, but an active participant in computational processes happening right here on Earth. It's as if these quantum devices are borrowing processing power from alternate versions of themselves scattered throughout the multiverse, using the computational resources of countless parallel realities to solve problems that would be impossible for any single universe to handle alone. The implications are staggering, suggesting that the boundary between theoretical physics and practical technology may be more porous than we ever imagined. String theory, our most ambitious attempt to unify all the fundamental forces of nature, pushes these ideas even further into the realm of the extraordinary. According to string theory, our familiar three-dimensional space might be embedded in a higher dimensional realm called the bulk. Imagine our entire universe as a thin soap bubble floating in a vast multi-dimensional ocean. In this framework, other soap bubbles representing parallel universe brains could exist mere millimeters away from us in the higher dimensional bulk, yet remain completely inaccessible because we're confined to our three-dimensional membrane. Like characters in a two-dimensional painting, we lack the dimensional freedom to step outside our cosmic canvas and explore the larger reality that contains us. Some versions of string theory suggest that what we perceive as dark matter might actually be ordinary matter existing on a parallel brane, its gravitational effects leaking through the higher dimensional bulk space into our reality, creating the mysterious gravitational influences we observe but cannot directly detect. It's a reminder that even the invisible components of our universe might be shadows cast by realities existing in dimensions we can't access. These theoretical frameworks push human comprehension to its absolute limits. They suggest that the familiar cosmos we observe through telescopes might represent just the tiniest fragment of a reality so vast, so complex, and so strange that even our most advanced theories can only hint at its true nature. The question of what lies beyond the edge of our universe reveals itself to be not just one mystery, but an infinite regression of increasingly profound puzzles. The holographic principle, emerging from our studies of black holes, offers yet another perspective on cosmic boundaries, suggesting that all the information contained within any volume of space can be encoded on its boundary, like a three-dimensional image projected from a two-dimensional surface. If this principle applies to our observable universe, then everything we see around us might be a projection from information encoded on our cosmic horizon. This holographic view turns our usual picture of reality inside out. Instead of asking what lies beyond the edge of our universe, we might need to ask what lies beneath it. What fundamental information processing system could give rise to the rich, detailed reality we experience? The vast cosmos we inhabit could be the shadow cast by patterns of information existing at the boundary of observation itself. These ideas bridge the gap between physics and philosophy, suggesting that consciousness and cosmos might be more intimately connected than our everyday experience suggests. If reality is fundamentally informational, then conscious observers like ourselves might not just be passive recipients of cosmic data, but active participants in the very process that creates and sustains existence. The cosmic microwave background, that ancient glow pervading all of space, carries within its subtle patterns the earliest possible information about our universe's structure and evolution. Studying this fossil radiation is like reading the universe's baby pictures, seeing the tiny quantum fluctuations that would eventually grow into galaxies and clusters of galaxies. But some cosmologists suggest that certain unusual features in this background radiation might be something even more extraordinary. Echoes of collisions between our bubble universe and neighbouring realities, imprints left by cosmic encounters that occurred before our observable universe even began its expansion phase. These potential signatures remain controversial and difficult to interpret, but they raise the tantalizing possibility that we might already possess observational evidence of realities beyond our cosmic boundary. Hidden in plain sight in the most ancient light we can detect might be proof that our universe has neighbours, that the cosmic foam of bubble universes predicted by inflation theory is not just theoretical speculation, but observable reality. If confirmed, such discoveries would represent humanity's first direct evidence that our cosmos is not alone in the vast sea of possibilities. The James Webb Space Telescope, humanity's most powerful eye on the distant universe, has begun revealing galaxies that existed when the cosmos was barely a few 100 million years old. These ancient stellar cities appear surprisingly mature and massive, challenging our understanding of how quickly cosmic structure can form. But even these most distant observations represent only the tiniest sample of what exists beyond our sight. The galaxies we observe at the very edge of our visibility are being carried away by the expansion of space itself, moving at speeds that approach the velocity of light. As dark energy continues to accelerate this expansion, more and more of these distant realms will cross the threshold of our future visibility limit, disappearing forever from our cosmic view as if they never existed. This means that the universe we can observe may actually be shrinking in the far future, even as space itself continues to expand. Entire cosmic neighborhoods, visible to us today, will fade beyond detection, leaving future astronomers with an increasingly isolated perspective on reality. They might never suspect that beyond their diminished cosmic horizon lies an infinite expanse of galaxies and wonders. The interplay between dark matter and dark energy creates a cosmic tension that shapes not just the evolution of our observable universe, but potentially infinite regions beyond our sight. Dark matter, the invisible scaffolding upon which all visible structure is built, forms vast networks of filaments extending far beyond our cosmic boundary, creating architecture on scales that dwarf our entire observable realm. Computer simulations suggest that this dark matter web stretches infinitely in all directions, connecting regions of space so distant that light from one end will never reach the other. The cosmic web we observe locally through gravitational lensing and galaxy surveys represents just one small section of an infinite network of invisible structure organizing matter on scales beyond human comprehension. Within this vast scaffolding lie cosmic structures we can never observe, superclusters larger than anything in our neighborhood, voids emptier than any we've discovered, gravitational architecture so massive it would revolutionize our understanding of cosmic evolution if we could somehow glimpse it. But it remains forever hidden beyond the horizon of possible observation. These hidden realms might contain phenomena that challenge our most basic assumptions about how universes work, regions where the balance between dark matter and dark energy differs from our local conditions, creating cosmic environments so alien they would seem like entirely different realities. Even while operating according to the same fundamental laws of physics, the question of what lies beyond the edge of the universe has led us on a journey through concepts that stretch human imagination to its breaking point. From bubble universes to quantum parallel realities, from higher dimensional spaces to holographic projections, from consciousness-based cosmologies to information-theoretic views of existence. Each possibility offers its own answer, yet none fully satisfies our cosmic curiosity. Perhaps this is the deepest truth we can discover about the nature of ultimate reality, that it will always exceed our capacity to fully comprehend it, that no matter how sophisticated our theories become, how powerful our instruments grow, there will always remain an infinite frontier of mystery beckoning us forward into ever deeper questions. The boundary between the known and unknown is not a wall to be demolished, but a horizon that recedes as we approach, always revealing new vistas of possibility, always inviting us to venture further into the cosmic ocean that surrounds and pervades our existence. The universe may not have an edge in any conventional sense, but it has given us something infinitely more precious. As you rest there in the gentle darkness, your mind drifting among these cosmic possibilities, you are participating in the most remarkable phenomenon in all of existence, conscious matter contemplating its own origins and limits, aware beings reaching beyond the boundaries of direct experience to touch the infinite with the finite instruments of thought and wonder. Somewhere beyond the furthest reaches of space and time, beyond the most distant galaxies and the most exotic theoretical constructs, lies the wellspring from which both consciousness and cosmos emerge, and to which they eternally return. It may be unreachable by any telescope or spacecraft, but perhaps it's accessible through the very act of wondering about it, through the quiet contemplation that connects finite minds to infinite mystery. The story of cosmic boundaries becomes even more intriguing when we consider that our entire conception of space itself might be an illusion created by the limitations of our three-dimensional minds. Trapped as we are in a reality that unfolds moment by moment in what we call time, we struggle to imagine existence that transcends these familiar categories. Yet the deepest theories of physics suggest that space and time themselves might be emergent properties arising from something far more fundamental. Imagine if the fabric of space-time, that seems so solid, so real, so obviously the stage upon which all cosmic drama unfolds is actually more like the surface of a vast ocean, appearing smooth and continuous from our perspective, but concealing turbulent depths of quantum activity beneath. At the smallest possible scales, space itself might dissolve into something discrete and granular, like pixels on a cosmic display screen. These Planck-scale dimensions, where our familiar notions of distance and duration break down completely, represent a realm where the usual rules of geometry and causality might give way to pure possibility. At these unimaginably tiny scales, smaller than any particle, smaller than any conceivable measurement, space and time might not be the smooth, continuous entities we experience, but rather a bubbling froth of quantum uncertainty. If this picture proves correct, then what lies beyond the edge of our universe might not be more space at all, but rather the computational substrate from which space itself emerges, the cosmic equivalent of the hardware running the software of reality. Our entire observable cosmos, with its hundreds of billions of galaxies, might exist as patterns of information, processing in some vast quantum computer whose architecture operates according to principles we can barely begin to fathom. This information-theoretic view of reality suggests something even more extraordinary, that consciousness itself might play a far more fundamental role in the cosmos than we ever dared imagine. If the universe is essentially composed of information patterns, then conscious observers like ourselves might not be mere passive recipients of cosmic data, but active participants in the very processes that create and sustain existence. Consider this deeply unsettling yet beautiful possibility. What if the boundary of our observable universe isn't determined solely by the speed of light and the finite age of the cosmos, but also by the reach of consciousness itself? What if the act of observation and contemplation actually extends the boundaries of what exists in ways both subtle and profound? Recent investigations into the nature of black holes have revealed something even more mysterious about cosmic boundaries. When matter appears to fall into a black hole, it seems to vanish completely from our perspective. Yet quantum mechanics insists with mathematical certainty that information cannot be truly destroyed. This creates what physicists call the information paradox, a fundamental conflict between two of our most successful theories about reality. The resolution of this paradox might require us to completely reconsider the nature of boundaries themselves. Black holes might not be the information-destroying monsters we once imagined, but rather cosmic gateways that transform and preserve information in ways we don't yet understand. The event horizon that marks the point of no return around a black hole might be remarkably similar to our cosmic horizon, a boundary beyond which we cannot observe, but which doesn't necessarily mark the end of existence. Some of the most elegant solutions to this puzzle propose that information appearing to be destroyed actually becomes encoded on the black hole's surface in a kind of cosmic hologram. This holographic principle suggests that all the information contained within any volume of space can be stored on its boundary, like a three-dimensional image projected from a two-dimensional surface. If the holographic principle applies to our entire observable universe, then everything we see around us, every star, every planet, every grain of cosmic dust, might be a projection from information encoded on the cosmic horizon itself. The vast three-dimensional reality we inhabit could be the shadow cast by patterns of data existing at the very edge of what we can observe. This holographic perspective turns our usual picture of cosmic reality completely inside out. Instead of asking what lies beyond the edge of our universe, we might need to ask what lies beneath it. What fundamental information processing system could give rise to the rich, detailed reality we experience as conscious beings embedded within it. The implications stretch far beyond academic physics. If our universe is indeed a holographic projection, then the question of what exists beyond its boundaries becomes a question about the nature of the projection system itself. Are we living inside a cosmic simulation run by some vast computational intelligence, or are we part of a natural information processing system that emerges spontaneously from the quantum foundations of reality? These ideas might sound like science fiction, but they emerge from serious attempts to reconcile our most successful theories about the fundamental nature of existence. They suggest that the cosmos might be far stranger and more mysterious than even our wildest speculations have dared to imagine. A reality where the distinction between mind and matter, between information and substance, might be far more fluid than our everyday experience suggests. The ancient philosophers spoke eloquently about the music of the spheres, the notion that celestial bodies create harmonious sounds as they move through space. While we now understand this isn't literally true, there remains something profoundly meaningful about the metaphor. The universe does seem to resonate with mathematical patterns and relationships that suggest an underlying order too beautiful and too precise to be merely accidental. These cosmic harmonies might be more than poetic flourishes. They could be genuine clues to the nature of whatever lies beyond our observational boundaries. If the universe is indeed a vast information processing system, then the patterns we observe, the mathematical relationships governing everything from subatomic behavior to galactic rotation, might be glimpses of the cosmic code, the fundamental algorithms that generate the reality we experience, the equations that describe quantum mechanics, the curvature of space-time, the evolution of cosmic structure, possess an elegance that seems to transcend mere utility, as if they were expressions of some deeper aesthetic principle woven into the very fabric of existence itself. This mathematical beauty might be more than coincidence. It could be evidence of a profound connection between the patterns of conscious thought and the patterns underlying reality. If mind and cosmos are more intimately related than we typically assume, then the mathematical harmony we discover in nature might reflect a deep kinship between consciousness and the fundamental structure of existence. The capacity to recognize beauty in equations, to find elegance in physical laws, might be a sign that awareness and cosmos spring from the same mysterious source. As we drift deeper into these theoretical landscapes, each more abstract than the last, it becomes clear that every major advance in human understanding has required abandoning cherished assumptions about the nature of reality. We once believed Earth sat motionless at the center of creation, that space and time were absolute and unchanging, that matter and energy were entirely distinct phenomena. Each of these seemingly obvious truths proved to be stepping stones on our journey toward deeper understanding. Perhaps our current assumptions about the universe, having an inside and outside, about consciousness being separate from physical reality, about information being distinct from the phenomena it describes, will prove equally provisional. The boundary between known and unknown reveals itself not as a wall to be breached, but as a horizon that perpetually recedes as we approach, always revealing new vistas of possibility, always inviting us to venture further into the infinite mystery that surrounds and pervades our existence. The universe may lack an edge in any conventional sense, but it offers us something infinitely more precious. Even now, as you rest in the gentle darkness, your thoughts drifting among these cosmic possibilities, you are touching something infinite, connecting your finite mind to unlimited mystery through the simple act of wondering about what lies beyond all observation, beyond all theory, beyond all possibility of direct experience. The ancient light of distant stars streams silently past your window, carrying messages from cosmic neighborhoods you will never visit, while your consciousness reaches out across impossible gulfs of space and time to contemplate realities that may exist in dimensions you cannot name or imagine. This reaching, this yearning, this profound curiosity might be the most remarkable phenomenon in all of creation. Somewhere in the vast expanse that extends beyond every horizon, beyond every theoretical construct, beyond every attempt at description, lies the source from which both questions and answers emerge, the wellspring that gives rise to consciousness and cosmos alike, to the capacity for wonder and to the infinite mystery that makes wonder possible. In this quiet moment, suspended between waking and sleep, between the finite and infinite, between what we know and what we can only dream, your mind becomes a bridge spanning the gap between the tangible world of everyday experience and the boundless realm of cosmic possibility. You are both infinitesimally small and cosmically significant, a temporary arrangement of stardust that has somehow become aware of its own cosmic context, able to contemplate not just the local neighbourhood of space and time, but the endless frontier of mystery that extends forever beyond the reach of any observation, any theory, any attempt to map the unmappable. The universe may not have an edge, but consciousness does something even more extraordinary. It creates meaning from mystery, finds beauty in uncertainty, and discovers profound connection in the very act of reaching toward what can never be fully grasped or completely understood. As your thoughts begin to settle, like cosmic dust after the passage of celestial winds, remember that the question of what lies beyond the universe's edge has led us not to a final answer, but to an appreciation of mystery itself. The recognition that the deepest truths about existence might not be destinations to reach, but horizons to approach with ever-growing wonder. The darkness around you is not empty, but full of possibility, not silent, but singing with the quiet music of infinite potential. Not an ending, but a beginning, an invitation to rest in the profound mystery that connects every conscious moment to the boundless cosmos from which it emerges and to which it eternally belongs. Somewhere beyond the furthest star, beyond the most distant galaxy, beyond the edge of space and time itself, the mystery continues unfolding, writing stories in languages we will never learn, asking questions we will never hear, answering them in ways we cannot imagine. Yet somehow, through the simple act of wondering, we participate in this cosmic conversation. The boundary between dreamer and dream, between consciousness and cosmos, between the question and its infinite answer, dissolves in the gentle darkness, leaving only the pure wonder that connects finite minds to unlimited mystery through the inexhaustible gift of curiosity itself. Rest now in this cosmic embrace, knowing that every breath connects you to the same infinite mystery that gives birth to stars and galaxies, to consciousness and dreams, to questions that have no final answers, and answers that inspire ever deeper questions in the endless dance between mind and cosmos that plays out in the theatre of existence itself. And perhaps, most beautifully of all, this infinite mystery ensures that wonder itself remains inexhaustible. No matter how much we discover about the cosmos, there will always be new questions emerging from the answers, new horizons beckoning beyond the ones we've just reached, new reasons to feel that familiar mixture of humility and awe that comes from being conscious in an unlimited universe. The concept of cosmic loneliness takes on new dimensions when we consider not just the spatial separation between distant regions, but the temporal isolation created by the universe's evolution. Imagine civilizations that existed billions of years ago in regions now forever beyond our reach. Their entire histories, their greatest achievements, their deepest questions lost, not to destruction, but to the simple passage of cosmic time. These ancient civilizations, if they existed, might have gazed up at their own night skies and wondered about the same mysteries we contemplate tonight. They might have developed technologies we can't imagine, philosophies that would revolutionize our understanding, sciences that dwarf our current knowledge. Yet the expansion of space ensures that no trace of their existence could ever reach us. No signal, no artifact, no whisper of their cosmic journey. This temporal dimension of cosmic isolation works in reverse as well. Somewhere in the far future, long after our own sun has exhausted its fuel and our galaxy has merged with Andromeda, there might be conscious beings looking out at a universe grown cold and empty, most stars having burned out, most galaxies having drifted beyond the reach of observation. These future observers will inherit a cosmos far lonelier than the one we know today, a universe where the cosmic microwave background has cooled to near absolute zero, where the last red dwarf stars flicker like dying embers in an ocean of darkness, where the very protons that make up matter itself might have begun to decay. Yet even in that distant epoch, so removed from our own time that the entire age of stars becomes just a brief flickering moment in cosmic history, consciousness might still emerge, still wonder, still reach out across the darkness to ask what lies beyond the boundaries of the known. This persistence of wonder across cosmic time suggests something profound about the nature of consciousness itself, that awareness and curiosity might be more fundamental to the universe than we typically imagine, not just accidental byproducts of complex chemistry, but expressions of something deeper woven into the very fabric of existence. The relationship between consciousness and cosmos becomes even more intriguing when we consider the role of language and mathematics in our cosmic explorations. The fact that we can describe the behavior of distant galaxies with equations that fit on a single page, that we can predict the evolution of the universe using mathematical tools developed to solve much simpler problems. This unreasonable effectiveness of mathematics, as the physicist Eugene Wigner once called it, suggests a deep connection between the structure of conscious thought and the architecture of reality itself. The patterns we discover in nature, the symmetries that govern physical laws, the elegant relationships between seemingly unrelated phenomena, might reflect something fundamental about the relationship between mind and cosmos. Perhaps consciousness isn't just an observer of cosmic patterns, but a participant in their creation, not in any mystical sense, but through the very act of pattern recognition that makes science possible. The universe might be structured in such a way that conscious observation and mathematical description are not external impositions, but natural expressions of its inherent organization. This participatory view of cosmic exploration suggests that the question of what lies beyond the universe's edge is not just about mapping unknown territories, but about understanding the nature of the mapping process itself, the relationship between the conscious minds asking the questions and the reality they're trying to comprehend. The tools we use to explore the cosmos, telescopes and particle accelerators, mathematical equations and computer simulations, are all extensions of human consciousness, ways of reaching beyond the limitations of our biological senses to touch realities that exist far beyond the scale of everyday experience. Yet each of these tools carries with it the limitations and assumptions of the minds that created them. Our theories about what lies beyond the cosmic horizon are necessarily shaped by our three-dimensional, four-dimensional experience of space and time. Our mathematics, while powerful, is built upon axioms and assumptions that might not apply to the deepest levels of reality. This suggests that the ultimate frontier might not be spatial or temporal, but conceptual, the development of new ways of thinking, new forms of mathematics, new modes of consciousness, capable of grasping realities that transcend our current categories of understanding. Some of the most revolutionary insights in the history of science have come not from gathering more data, but from fundamentally shifting perspective, from thinking of Earth as the center of the universe, to recognizing it as one planet among many, from viewing space and time as separate absolutes, to understanding them as aspects of a unified space-time fabric. Perhaps the next great revolution in in our understanding of cosmic boundaries will require a similar conceptual leap, a recognition that our familiar categories of inside and outside, of here and there, of now and then, might be as provisional and limited as the geocentric model of the cosmos once seemed obvious and eternal. The quantum mechanical picture of reality already hints at such conceptual revolutions, with its suggestion that particles can exist in multiple states simultaneously, that the act of observation plays a fundamental role in determining what becomes real, that information and probability might be more fundamental than the classical concepts of matter and energy. These quantum insights suggest that the boundary between the known and unknown might not be a fixed line in space, but a dynamic interface between possibility and actuality, between the realm of potential and the world of manifest experience. In this quantum view, what lies beyond the edge of our observable universe might not be more of the same types of structures we see locally, but rather a vast ocean of unrealized potential waiting to be collapsed into definite states through some form of cosmic observation or measurement. This possibility raises profound questions about the role of consciousness in cosmic evolution. If observation plays a fundamental role in quantum mechanics, does this mean that conscious observers, like ourselves, are not just passive witnesses to cosmic history, but active participants in its unfolding? The implications stretch far beyond physics into philosophy and even theology, suggesting that the universe might be fundamentally relational rather than mechanical, a web of interconnected observations and experiences rather than a collection of separate objects moving through empty space. These ideas remain highly speculative at the frontier of current scientific understanding, but they illustrate how the question of what lies beyond the universe's edge continues to push us toward ever more fundamental reconsiderations of the nature of reality itself. As we drift deeper into these conceptual waters, it becomes clear that the cosmic journey we've undertaken tonight is as much about inner exploration as outer discovery. Each new theoretical horizon we've contemplated has required us to expand not just our knowledge, but our capacity for wonder, our willingness to embrace mystery, our ability to hold multiple possibilities in creative tension. The universe we've explored together exists not just in the vast reaches of space and time, but in the intimate space between your ears, where neurons fire in patterns that somehow give rise to thoughts about infinity, where electrical impulses become contemplations of eternity, where the chemistry of consciousness reaches out to touch the deepest mysteries of existence. This neural universe, with its billions of interconnected cells, its intricate networks of communication, its capacity to model realities far beyond its direct experience, might be the most remarkable structure we know of in the cosmos. More complex than any galaxy, more mysterious than any black hole, more profound than any theoretical construct. The fact that such structures can emerge from the same fundamental particles that make up distant stars and planets suggests a deep unity underlying all the diversity we observe in nature. Consciousness and cosmos might be different expressions of the same underlying reality, different movements in the same cosmic symphony. As you rest there in the gentle darkness, your breathing slowing, your thoughts beginning to settle like leaves falling softly to the ground, you are both infinitely small and cosmically significant, a temporary eddy in the vast current of cosmic evolution, yet somehow able to contemplate the whole of which you are a part. The question of what lies beyond the edge of the universe has taken us on a journey through concepts that stretch human understanding to its limits, from the curved geometry of space-time to the quantum foundations of reality, from the possibility of infinite parallel universes to the holographic nature of cosmic boundaries. Each possibility we've explored offers its own answer to our original question, yet none provides the final definitive response that would end our cosmic curiosity. Perhaps this is the deepest truth we can discover about ultimate reality, that it will always exceed our capacity to fully comprehend it, that mystery is not a temporary gap in our knowledge, but a permanent feature of existence itself. This inexhaustible mystery is not a limitation but a gift, ensuring that wonder remains fresh, that curiosity stays alive, that each generation of conscious beings will find new horizons to explore, new questions to ponder, new reasons to look up at the night sky with awe and humility. The boundary between known and unknown reveals itself to be not a wall separating us from truth, but a membrane through which wonder flows, connecting finite minds to infinite possibility through the simple, profound act of asking questions that have no final answers. Somewhere beyond the furthest reach of space and time, beyond the most exotic theoretical construct, beyond every attempt to map the unmappable, lies the source of all questions and all wonder, the wellspring from which consciousness and cosmos alike emerge and to which they eternally return. You touch that source now, in this quiet moment of contemplation, as your awareness expands to embrace possibilities that stretch beyond all observation, beyond all theory, beyond all hope of final comprehension. The darkness around you is not empty, but pregnant with potential, not silent, but humming with the quiet music of infinite mystery. The universe may not have an edge in any conventional sense, but it has given us something far more precious: the capacity to wonder, the ability to reach beyond every boundary, to touch what cannot be grasped, to know what cannot be fully understood. As your consciousness begins to drift toward the threshold of sleep, remember that you carry within you the same cosmic mystery that gives birth to stars and galaxies, to space and time, to questions and dreams. The boundary between inner and outer, between mind and cosmos, dissolves in the recognition that wonder itself is the bridge that connects finite awareness to unlimited mystery. Rest now in this cosmic embrace, knowing that every breath connects you to the infinite, every heartbeat participates in the rhythm of creation, every moment of awareness touches the same profound mystery that lies forever beyond the edge of everything we can know, yet somehow lives at the very heart of who we are. The journey continues, even as consciousness fades into sleep, for the mystery that lies beyond all boundaries, beyond all edges, beyond all attempts at definition, is also the mystery that dreams and wonders and reaches eternally toward what can never be fully grasped, but can always be more deeply appreciated. In the gentle darkness that surrounds you now, the infinite cosmos continues its patient unfolding, writing new chapters in the endless story of existence, asking questions in languages we will never learn, answering them in ways we cannot imagine. Yet somehow, through the simple act of wondering, we participate in this cosmic conversation that has no beginning and no end. Somewhere in the depths of sleep, your mind continues its cosmic wandering, drifting through theoretical landscapes where the familiar boundaries of space and time dissolve into something far more mysterious and profound. The questions we've explored tonight echo through the corridors of consciousness, even as awareness fades, reminding us that the greatest discoveries often come not from finding answers, but from learning to ask better questions. And perhaps that's the most beautiful truth of all about our cosmic predicament, that we are conscious beings capable of contemplating our own cosmic context, able to reach across impossible gulfs of space and time to touch mysteries that will forever remain just beyond our grasp, yet somehow, through the very act of reaching, we participate in something magnificent. The accelerating expansion of our universe, driven by dark energy, creates a kind of cosmic horizon that recedes faster than we can ever hope to approach. Entire regions of reality slip away from us, not because they cease to exist, but because the fabric of space itself carries them beyond the reach of any possible observation. It's a reminder that the cosmos is not a static museum of wonders waiting to be catalogued, but a dynamic, evolving system where even the boundaries of the knowable shift and change. This cosmic recession might seem melancholy at first glance, like watching friends disappear into fog, knowing you'll never see them again. But there's something almost liberating about it too. It means that no matter how advanced our technology becomes, how sophisticated our theories grow, the universe will always retain an element of mystery that no amount of scientific progress can eliminate. The implications stretch far beyond astronomy into the realm of meaning itself. If the universe is fundamentally inexhaustible in its mystery, then wonder becomes not just a temporary response to ignorance, but a permanent feature of conscious existence. We are not destined to solve the cosmic puzzle and retire satisfied, but to engage in an eternal dance with mystery that grows richer and more intricate with each step. Perhaps this is what lies beyond the edge of the universe, not more space or time, or even parallel realities, but the inexhaustible capacity for amazement itself, the recognition that consciousness and cosmos are engaged in an endless conversation where each answer births new questions and each discovery reveals new depths of mystery waiting to be explored. As your breathing deepens and your thoughts begin to settle into the gentle rhythms of approaching sleep, remember that you are part of this cosmic conversation, not as a passive observer, but as an active participant. Your capacity for wonder, your ability to contemplate mysteries that stretch beyond all observation, makes you a collaborator in the universe's ongoing project of understanding itself. The darkness that surrounds you now is not empty, but full of potential. Not the absence of light, but the presence of infinite possibility, where dreams and reality meet, where consciousness touches the infinite, where the question of what lies beyond every boundary finds its answer not in facts and figures, but in the simple recognition that some mysteries are meant to be lived rather than solved. The cosmic journey we've shared tonight may be ending, but the wonder it has awakened continues, like ripples spreading across the surface of a cosmic pond. Each thought, each moment of amazement connects you to the same infinite mystery that moves galaxies through space and time, that gives rise to consciousness itself, and that ensures no matter how much we learn, there will always be new reasons to look up at the night sky with fresh eyes and an open heart. Somewhere beyond the edge of everything we can know or imagine, the universe continues its patient unfolding, writing stories in languages we will never decipher, answering questions we will never think to ask. Yet somehow, through our willingness to wonder, through our capacity to reach beyond every boundary, we touch the infinite and find that it touches us in return. Sleep now in this cosmic embrace, knowing that the mystery that lies beyond all edges, beyond all theories, beyond all hope of final understanding, is also the mystery that dreams and wonders and loves through conscious beings scattered across space and time, each one a unique window through which the universe contemplates its own magnificent, inexhaustible depths. The ancient light that streams through your window tonight carries with it the accumulated wisdom of billions of years. Each photon is a messenger that has travelled impossible distances to reach your eyes, bearing witness to cosmic events so distant they predate the formation of our solar system. Yet here they are, painting gentle patterns on your ceiling, whispering stories of stellar nurseries and dying suns, of galaxies spinning in the darkness, and perhaps of other worlds where other conscious beings are asking the very same questions we've explored together. This convergence of light and consciousness in the quiet sanctuary of your room represents something profound. The universe folding back upon itself, becoming aware of its own existence through the delicate neural networks that fire behind your eyes. It's as if the cosmos has developed a way to observe itself from the inside, to contemplate its own depths through the temporary arrangements of matter we call minds. And what a privilege it is to be one of those arrangements, to be the universe's way of knowing itself, even if only for the brief flicker of a human lifetime. Somewhere in the vast dark between stars, There might be other flickering lights of consciousness, other beings gazing up at their own night skies and feeling that same mixture of insignificance and wonder that comes from recognizing your place in something infinitely larger than yourself. The questions we've pondered tonight about cosmic boundaries and parallel realities, about the nature of space and time and consciousness, may never find complete answers, but perhaps that's exactly as it should be. Perhaps the universe, in its infinite wisdom, has structured itself in such a way that mystery remains inexhaustible, ensuring that conscious beings will always have reasons to wonder, to explore, to reach beyond the comfortable boundaries of the known. As your eyelids grow heavy and your thoughts begin to blur at the edges, like watercolours in gentle rain, remember that this moment of drift between waking and sleeping is itself a kind of cosmic boundary, a threshold between one state of consciousness and another. You cross such boundaries every day, between dreaming and waking, between thought and feeling, between self and other, between the finite experience of being human and the infinite mystery of existence itself. The universe may not have an edge in space, but consciousness creates its own boundaries and then transcends them with every act of imagination, every leap of understanding, every moment of connection between one mind and another. We build bridges across the void, not with matter and energy, but with meaning and wonder, with the simple recognition that we are all part of the same vast unfolding story. Perhaps that's what truly lies beyond the edge of the universe. Not more galaxies or dimensions or parallel realities, but the recognition that the boundary between self and cosmos, between mind and matter, between question and answer, is far more fluid than we typically imagine. That consciousness is not separate from the universe, but the universe becoming aware of itself through countless unique perspectives scattered across space and time. Tonight, you've joined that cosmic conversation. You've allowed your mind to expand beyond the familiar boundaries of everyday experience, to touch possibilities that stretch beyond all observation, to participate in humanity's ongoing dialogue with mystery itself. In doing so, you've become part of something larger than any individual consciousness, yet intimate enough to feel in the quiet rhythm of your own breathing. The weary researcher in you, the part that wonders and questions and reaches toward the infinite, is not separate from the vast cosmos we've explored tonight, but an expression of it. Consciousness looking at consciousness, cosmos contemplating cosmos, mystery recognizing itself in the mirror of an aware mind, floating gently toward the threshold of dreams. Somewhere beyond every horizon we can imagine, beyond every theory we can construct, beyond every boundary we can conceive, lies the source of all questions and all wonder, the wellspring from which both cosmos and consciousness emerge and to which they eternally return. It cannot be reached by any telescope or spacecraft, but perhaps it touches us in moments like this, when the mind relaxes its grip on the familiar and allows itself to float free in the ocean of infinite possibility. As sleep finally claims you, remember that the journey continues even in dreams. For the unconscious mind is also part of this cosmic conversation, weaving together fragments of wonder into new patterns of possibility, creating connections that the waking mind never imagined, processing the infinite in its own mysterious way. Rest now, knowing that you carry within you the same stardust that forms distant galaxies, the same curiosity that drives the universe to know itself, the same capacity for wonder that transforms mere matter into conscious observers capable of contemplating their own cosmic significance. The question of what lies beyond the edge of the universe remains beautifully unanswered, a gift that keeps on giving, ensuring that tomorrow and all the tomorrows after will still hold mysteries worth pondering, horizons worth approaching, reasons to feel amazed by the simple fact of existence in a cosmos too vast and strange and wonderful for any finite mind to fully comprehend. And in that incomprehension, in that eternal mystery, lies not frustration, but freedom. the freedom to wonder without end, to explore without exhausting the territory, to find meaning not in final answers, but in the quality of the questions we ask and the depth of wonder we bring to the eternal conversation between mind and cosmos. Good night, fellow traveller in this infinite universe. May your dreams be filled with cosmic wonder, and may you wake tomorrow with fresh questions and renewed amazement at the extraordinary fact that anything exists at all, including the remarkable consciousness that makes it possible to ask what lies beyond the edge of everything.